The problem with Hong Kong was not money, not politics, and not ambition. The problem was geometry. 7.5 million people crammed into a territory the size of a small county, surrounded by mountains and sea on every side, and the one airport serving all of them sat wedged inside a dense urban neighborhood with one runway, one approach corridor, and absolutely nowhere to grow. Kai Tak Airport had operated in the middle of Kowloon since 1925. By the time jet travel became the norm, pilots approaching runway 13 had to execute a sharp right turn at low altitude, lining up visually on a checkerboard painted on a hillside, then dropping through a gap in the city with apartment towers on both sides, close enough that passengers reportedly made eye contact with residents on their balconies. That approach was not a quirk. It was a structural consequence of building a major international airport in a place that never had room for one. And Kai Tak could not expand. The mountains behind it were fixed. The city around it was built solid. The harbor in front of it was shared, shallow, and already busy. For decades, planners accepted the constraints and worked around them. But by the late 1980s, Hong Kong's passenger numbers were climbing toward capacity. Cargo demand was accelerating, and the approach had become one of the most technically demanding in commercial aviation. The question was no longer whether to replace Kai Tak. The question was where, physically, an airport could go. The answer the engineers arrived at was to build the land first and then build the airport on top of it. Chek was a small island off the northwestern coast of Lantau, about 30 kilometers west of the old Kai Tak site. It was not large enough for an airport on its own, but it sat in relatively shallow water beside another small island called Lam Chau, and the geography of the seabed between and around those islands made large-scale reclamation technically possible. The plan was to level the existing islands almost entirely and use the material from that demolition, combined with dredged sand and fill, to create a flat platform in the sea large enough for a full international airport with 2 runways. The scale of what that actually required is where the project departs from ordinary large construction. The Reclamation program created a platform of roughly 1,248 hectares, which is an area of land that simply did not exist before construction began. Chek Island itself was reduced from its natural profile to near sea level, stripped down so that its granite core could become part of the new ground. The seabed was excavated, consolidated, and built back up in layers engineered to carry the weight of terminal buildings, fuel systems, runways, and the continuous stress of aircraft operations over decades. What nearly defeated the project was not any single dramatic failure, but a compounding series of engineering tolerances that had to hold simultaneously across an artificial surface that had never settled naturally. Reclaimed land behaves differently from bedrock. It compresses unevenly under load, shifts with tidal pressure, and can develop differential settlement, meaning one section of ground sinks faster than an adjacent section, which is catastrophic for a runway that needs to remain within millimeters of level across its entire length. The engineers had to predict how the fill would behave over years and design the ground treatment to constrain that movement before any surface structure was built. The approach they used combined deep compaction of the seabed with controlled placement of fill material in sequences designed to let the ground consolidate under its own weight before the next layer was added. In areas where the natural seabed was soft marine mud, the mud was either removed entirely or treated with vertical drains to accelerate the compression that would otherwise take decades to occur on its own. The goal was to force most of the settlement to happen during construction rather than after, so the finished surface would be stable enough to carry a terminal and runways that cannot flex or shift. The airport also did not go up in isolation. The project was part of a larger infrastructure program that included a new rail line connecting the airport to the urban core, a series of new road and bridge links across Lantau, and a reconfiguration of how the entire western approach to Hong Kong functioned. The airport site was so far removed from existing infrastructure that the access network had to be built essentially from scratch alongside the airport itself. That meant the construction timeline was not just about finishing buildings. It was about finishing a web of interdependent systems that all had to be operational before the airport could open. Kai Tak closed on July 6, 1998. Hong Kong International Airport at Chek opened the following day. The transition moved one of the busiest airports in Asia from a landlocked urban site with a notorious single runway approach into a two-runway facility built on ground that had been ocean floor less than a decade earlier. The physical move of the airport, measured in distance, was about 30 kilometers. Measured in engineering ambition, it was the creation of a new piece of the planet. There are legitimate questions about what reclamation at that scale costs in other terms. Shallow coastal waters around Lantau supported marine ecosystems and fishing communities, and large-scale dredging and infill permanently altered the seabed and the tidal patterns of the surrounding waters. These consequences were real and documented, and they represent the kind of trade-off that does not show up in the construction budget but does show up in the environment for generations. The airport delivered the capacity Hong Kong needed. What it displaced is harder to quantify and does not disappear simply because the runways work. Today, Hong Kong International Airport is consistently ranked among the busiest cargo airports in the world and handles tens of millions of passengers annually. The two-runway configuration that was impossible at Kai Tak operates in open airspace over water, without the terrain constraints and urban obstacles that made the old approach one of aviation's most demanding procedures. The checkerboard on the hillside above old Kowloon is gone. The apartment towers that once framed a descending 747 are still there, but the planes no longer come. The engineering decision that made the airport work was not the terminal design or the runway layout. It was the choice to treat the seabed as a construction site rather than a boundary. Every other constraint flowed from geography. The answer to every geographic constraint turned out to be make more geography. That logic, that the land itself could be an engineering product, is what turned a problem with no visible solution into an airport that has now been operating in the South China Sea for more than 25 years. The real question the Chek project leaves open is not whether reclamation works. The airport proves it does. The question it raises is what it costs to build a city outward into the water indefinitely, and whether the math that justified one airport continues to hold when the same logic is applied to housing, to highways, to entire new districts. Hong Kong has kept reclaiming. The answer to that question is still accumulating. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.